afternoon. Today the topic is SAG problems with towers unequal heights. Problems on SAG with towers unequal heights. So the map to course outcome 2. So problem, the towers of heights 30 meters and 90 meters respectively support transmission line conductor at river at water crossing. So given towers heights 30 meters and 90 meters, unequal heights. Okay, so and it is mentioned that the towers are at water crossing. So um, so the towers are located on the on the river side, let us say. Next, horizontal distance between the towers is 500. L is given, span length 500. Tension in the conductor 1600 kg. Tension directly given, capital D. Find the minimum clearance of the conductor and water, and clearance midway between the supports. Here it is asked two things. Okay, first one is minimum clearance of the conductor and water, first thing, and the second one is clearance midway between the supports, the clearance at the midpoint of the conductor. Okay, midpoint between the supports. So that is those are the things they ask. And weight of the conductor given 1.5 kg per meter. Bases of towers can be considered to be at water level. Okay, so mentioned that the tower's basement is at the water level. So based on the given, that is a problem given. So now based on the given problem, we have to draw the uh, diagram with towers. Okay, between them the transmission line. So it is how you can see in the slide, the diagram. So it is clearly given the towers are at different heights. Okay, so one is 30 meters, another one is 90. So you can see tower A is the lower level support, which is 30 meters height, and uh, tower B is 90 meters, okay, above the water level. And it is mentioned the length, span length is shown 500. And we know that when towers are at unequal heights, how to calculate the sag. Okay, so in that case, we have, with respect to the two towers, two sag, okay, S1 and sag S2. So we have expression. uh, so we first calculate this sag based on the concept. Okay, towers unequal heights, we calculate this. Then using this data, we see what we can find what they asked in the problem. Okay, they asked minimum clearance of the conductor and water. Okay, that is the first thing they ask. So for minimum clearance we can calculate. Okay, so first, so here see that, using, write down the given data, roughly drawn the diagram like this, showing all the parameters. Okay, so sag S1 is a lower level support sag from the lowest point of the conductor, and sag S2 is the higher level support sag with respect to the lowest point of the conductor O. Okay, next, x1 is the distance of the lower level support from the lowest point of the conductor. X2 is the distance of the conductor from the distance of the higher level support from the lowest point of the conductor. Now, uh, now, uh, then we have the expressions. We have the expressions for x1, x2. Then we can calculate S1, S2. So here, start solving. So given data, L is given 500, W weight of the conductor given 1.5 kg, tension in the conductor 1600 kg, difference in levels between supports. Okay, H, small h. Okay, we know that So that is nothing but difference of the two heights, 90 minus 30, so which gives 60. Then they also given span length 500 meters, means that is nothing but sum of okay, x1 and x2, right? So from the diagram, so that is equal to 500. Now, we know that this is sag s1, sag s2 expressions. Double sag s1 is wx1 square by 2t, ws2 is wx2 square by 2t, and we know that we have the formula for x1 and x2 directly, or we can calculate, simplify like this, okay, from the starting using the concept, okay, or we have the expressions, direct expressions for x1 x2 we already derived in the concept. X1 is L by 2 minus TH by WL. um, so all the data is given, okay, here to calculate x1, and x2 is L by 2 plus TH by WL. So that is how x2 can be calculated. So here substituted the given data in these expressions. Okay, yes or no? So L is given, okay, span length, T tension in the conductor, H is nothing but difference in levels between the support, small h, and W is the weight of the conductor, and small l is again length of the span. So substituted the values, okay, so x1 x2 are calculated, and you see x1 value is 120 meters and x2 is 378 meters, okay. So that is how first x1 x2 calculated. Now come to calculating sag s1, sag s2, okay. So here in the problem what they asked, okay, they are not asked about the sag directly, but they ask minimum clearance of the first bit, okay, first part they asked minimum clearance of conductor and water. So here minimum clearance of conductor and water nothing but at the that is a from the lowest point of the conductor we get the minimum clearance, right, from the lowest point of the conductor to the ground level, okay. So that means this distance, this value we have to calculate for the first bit. So for that, what we can do, so one way is, okay, we can do other way also. So what we can do is to calculate this value, calculate sag s1, calculating sag s1, okay, we have the formula for s1, okay. So after that we know the height of the tower A, lower level support A, 30 meters. So total height of the tower A minus this S1, sag S1, will give the minimum clearance of the conductor and water, right? Minimum clearance of conductor and water. Okay. So that is a first part. Okay. So that is what it is done. So S1 is calculated. S1 is calculated. Okay. S1 is calculated. So which is Wx1 square by 2t. Okay. X1 is 122 substituted. Remaining values are already known. So which is obtained as 7 meters. Okay. Now, clearance of minimum clearance, right? We want. So, clearance of lowest point O from the water level is, what is the height of the tower A? 30 meters, right? Height of the tower A is 30 meters minus S1. Okay. So, which is, whose value is obtained as 23 meters. 23 meters. Okay. That is the first part. Okay. First part done. Next, look at the second part. What they ask, clearance midway between the supports. Clearance midway between the supports. So at the midpoint they want the clearance. Okay, that means at the midpoint of the conductor, they want the clearance. So here, let us see here, look at the diagram. Let us say that P be the midpoint. We don't know exactly. Okay, of course, P to length of the span is 500 meters means midpoints means okay. It is at a distance of 250 meters from any one of the tower. So now, let us say that P be the midpoint. Okay, P be the midpoint, which is at a distance of x meters from the lowest point O. Okay, so it is taken that x be the distance of the midpoint from the lowest point O. Okay, then what is this x value? What is this x value? So that x value is given by, because we know that P is the midpoint, right? So 250 minus this x1. Okay, so the midpoint is the x value is given by 250. Okay, 250 minus x value is given by 250 minus x1. Okay, now calculate the sag corresponding to this distance. Okay, because we know at the lowest point what is a sag, what is a clearance. So based on that data, okay, remaining part we are doing. Okay, so midpoint distance is considered, and with respect to that distance, the sag is calculated. That is mentioned as S mid. Okay, at mid, that means midpoint. So wx square by 2t again. Okay, that basic formula is fixed, wx square by 2t. So w value, t value fixed, only x value is 128 substituted, which is obtained as 7.68. Okay, 7.68. Now this is only at the midpoint, the sag value. Okay, so now we want the clearance at this midpoint, right? So we know that okay, now this value. Okay, we calculated at the midpoint what is the sag. Okay, so now how the clearance can be obtained at this point? That means this value. Okay, because we know already this clearance value, okay, from the lowest point of the conductor. So add that value to this S mid value. Okay, S mid value. Okay, that gives the add the lowest point clearance value with the S mid. Okay, so we calculated at the midpoint what is the sag. This value is calculated. Okay, we know that sag means from the lowest point to the point of the particular tip of the tower. Okay, here tower means at the midpoint we want, so that is we calculated, mentioned as S mid. Okay, midpoint, at the midpoint calculated sag. So add this value with the lowest point sag. Okay, lowest point clearance will give you the clearance at the midpoint. So that is what it is done. Okay, what is that value? Already we know 23, right? So clearance at the lowest point 23 added with this mid value as the mid value 7.68. Okay, so that is how the problem with unequal heights, towers with unequal heights, okay, is solved. Next, one more problem based on the same data, similar problem. We'll see. An overhead transmission line at a river crossing is supported from two towers of heights 40 and 90 meters above water level. The horizontal distance between the towers being 400 meters. If the maximum allowable tension is 2000 kg, find the clearance between the conductor and water at point midway between the towers. Okay. Weight of the conductor is given 1 kg per meter. Here it is asked clearance between the conductor and water at the midpoint. Again at the midpoint only. Okay. At the midpoint only they want the clearance. Like previous problem, but here only one part, only one thing they asked. Okay. So it's the same thing, two tower heights are given 40 meter, 90 meter, different heights, say the towers A and B. So based on the given data, the diagram is drawn. You can see on the slide. And length of the span 400 meters. Tension is 2000 kg. And the weight of the conductor 1 kg per meter. Now we know that we have to mention x1, x2. Okay. X1 is the distance of the lower level support from the lowest point. X2 is the distance of higher level support from the midpoint. Now, calculate x1, x2. First, okay, we have to calculate for this kind of problems. Always, first we have to calculate x1, x2. Okay. So, after calculating x1, x2, so this is how it is solved. Okay. So, using the same expressions, x1 is L by 2 minus TH by WL, x2 is L by 2 plus TH by WL. So, x1 is obtained as negative value, okay, it is minus 50, and x2 is 450 meters. Okay, as I mentioned, we can use this formula directly, okay, or we can solve like this from the concept wise also. This is how actually this formula are derived, okay, you from this only, from this concept only. Okay, so x1 is obtained as negative value minus 50, x2 is 450 meters, which means what? But length of the span, what is that given? Distance between the towers 400 meters. So that means what? The negative value of x1 indicates, okay, the lowest point of the conductor is not between the towers, it is out of the towers. Okay, it is not between the towers, it is, okay, it is outside the both towers. So based on this knowledge, the diagram is redrawn. Previously we have drawn, okay, rough diagram. Okay, now the diagram is redrawn like this. See, between the towers A and B, okay, conductor is there, but its lowest point O is, okay, it is out of the two supports. Okay, that is how, okay, the diagram for this problem. So now mark the same, give same data. Okay, x1 is 50, x2 is 450, right? Right, I hope it is clear, because we know the distance between the two towers is 400. So x1 is negative means it is shown out of the, okay, two supports. So next x2 also started from the out of the two supports from the lowest point. Okay, now we want to calculate at the midpoint the clearance, right? So here the same manner like previous, consider P be the midpoint. Okay, P be the midpoint at a distance of x meters from the lowest point of the conductor. Okay, now what is the x value now? What is the x value now? It is given by, it is given by, uh, it is given by, definitely, if we are, okay, writing with respect to lower level support, 50 plus 200, right? 50 plus 200. X value is, okay. So it is at a distance of x meters. It is, and this is the midpoint, right? So 200 added with, okay, 50 meters. Now calculate the side at this midpoint. That is estimate. Okay. So estimate is calculated. This value is calculated. Okay. W x square by 2t. Okay. Substituted x value along with weight of the conductor and tension 15.6. Now we want to calculate the clearance at this midpoint. Already this data is known. Estimate is known. This distance is known. Okay. So if we know this value, okay, we have to know this value to get the clearance. How to know that value? How to know that value? One better thing is, like previous idea, okay, calculate S2, right? Calculate S2, then calculate the okay, height of the point B above midpoint. Okay, so that is calculated. See, okay, first S2 is calculated. S2 is calculated. S2 is calculated. Okay, so this is obtained. This is S2. This S2 is obtained, right? So now, okay, after obtaining this S2, what we can do? Okay, we can get this value, right? This value, okay, this value. How height of this tower is how much? Height of this tower is how much? Tower B is 90, right? So this value is obtained as we can, okay, this is another way they have done, but whatever we have done in the previous problem, same manner I'm following here also. So the clearance, okay, minimum clearance, I'm calculating clearance is, what is that? 90, okay, 90 minus 50.6. So 90 minus 50, how much? 40, right? So 39.4, okay. So 39.4 is, if we add that to 50.6, 15.6, I think. Yes. So this manner like previous problem, right? So with respect to S2, I calculated this clearance, okay. So then this value is added with S2, estimated, okay. So this value is 39.4 I have obtained. Okay. So finally at the midpoint, what is the clearance? 39.4 plus 15.6. Okay. Estimate value will give us the clearance at the midpoint. Okay. That is answer 55. Pink color one, 55. This is the answer. Okay. So here one other way is explained. Of course, you can understand that one also. Anyway, so this is a problem again. Towers with unequal height. These are my references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.